All right, let's try another problem. Let's take the limit as x approaches -1 of x plus 1 all over the square root of x plus 5 minus 2. And so I'm going to first, as always, try direct substitution. And if I plug -1 in, I'm going to get -1 plus 1 all over the square root of -1 plus 5 minus 2. And that gives me 0 over -1 plus 5 is 4, and take the square root of that is 2, minus 2 is 0. So again, we have that indeterminate form, and we cannot stop at that point. We don't know that the limit does not exist, and so we need to try to change the form in some way to see if it exists. And so the technique we're going to use is called rationalizing, and it's based on the difference of two squares formula. If you recall from algebra, we know that a minus b times a plus b is equal to a squared minus b squared. And using that, we also know that the square root of a minus b times the square root of a plus b then would be square root of a times the square root of a is just a, and then minus b times plus b is minus b squared. Okay, and so we're going to multiply the denominator by its conjugate, and I think you've done this probably in algebra too. So the limit as x approaches -1 of x plus 1 all over the square root of x plus 5 minus 2. We're going to multiply that by the square root of x plus 5 plus 2. Again, we're using the difference of squares, something like this. And if we do that to the numerator, remember we also have to multiply the denominator times the same thing. So in essence, we're just multiplying this problem by 1. That right there is 1. So it's not changing the problem. And let's simplify then. So we get the limit as x approaches -1. In the numerator, we have x plus 1 times the square root of x plus 5 plus 2. And in the denominator, we have this term times this term would give us x plus 5. And then minus 2 times plus 2 is equal to minus 4. So again, keep simplifying. We get the limit as x approaches -1. We get x plus 1 all over the square root of x plus 5 plus 2. And in the denominator, we have x plus 5 minus 4 is actually x plus 1, isn't it? So look what happens here. We have this factor in the numerator and in the denominator. And like I said in the last video, since we're not concerned what happens exactly at -1, we can actually cancel these. And we know that the square root of x plus 5 plus 2 behaves just like this function everywhere except at x equals -1, right? So I'm going to now take the limit as x approaches -1 of this function, and I get the square root of -1 plus 5 plus 2, which is equal to the square root of 4, which is 2 plus 2, and that's 4. So my answer is the limit as x approaches -1 of x plus 1 all over the square root of x plus 5 minus 2 is equal to 4. And again, that technique is called rationalizing.